Class, this is number 17. It's also an online problem. Okay, so we have arranged your class boundaries 49.5 to 58.5 and so on. This is just the data coming out of the problem. They're saying that 19 occur in this range, 61 occur in this range, 82 occur in this range, 34 in this range, 4 occur in this range. They're telling us our alpha value is 0.01, and these add up to 200. So we can use those later. So the big question is this a norm? Does this fall into a normal curve? Well, a normal curve would look like this. Okay, we'd have this range here, so many, 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 this range here, so many. Okay, is this data a normal curve? Okay, lastly, our HO will always be this distribution is normal. HA is it's not normal. So those would be your HA is always or HO is always equal. HA is always not equal. Kind of those type of things. So for example, or problem number 17, the first thing it wants us to find is the expected frequency. Okay, so here's what I've done. Put it into your calculator, edit. Okay. Put the range in here divided by 2. So this would be the midpoint of that first range. So here's how I did this. I went parentheses, 49.5, which is the class low number of the first class boundary, the lower limit, plus 58.5, end parentheses, and then I did divided by 2. Okay? And then the same thing here in this second one. For open parentheses, 58.5 plus 67.5 divided by 2. I did the same thing for all of these, and they just came up with 54 and then adding 9 to each of them. Those are the midpoints. This is your frequencies. This is how many have an average of 54. How many have an average of 61? How many have an average of 82 in this range? Or 82 have an average of 72, excuse me. 34 have an average of 80, 81, and so on. So first thing we need to figure out is what is the expected value? Okay, well, to do that, we have to run one var stats on this. So I'm going to quit out of here, stat, go to calculate, one var stats. Okay, and I'm going to use L1 as my list, those averages, and L2 is the frequency, how many are occurring in each of those averages. Go to calculate, okay, and it gives me some data here. This data will all be stored on the calculator, which is nice. So I'm going to go back to the list. Okay, how do I get this number right here, what we're expecting in this spot? Well, I'm going to go normal CDF. Okay, number 2, and put in the range of the first one. So the range of the first one is 49.5. That's the lower number, the lower limit on the first class boundary, to 58.5. Okay, and then here you're going to put X bar to find X bar. After you run one var stats, you get all this data saved. So X bar is in vars, number 5, and it's number 2. Okay, and then you want to, for the standard deviation, you want to use SX. Again, that's in vars, number 5, number 3. Okay, hit enter. Now I want this number to be taken times the total of this number. So in some problems they're going to give it to you. They did in this problem. They said we have a total of 200 tests. Okay, but if it's not given to you and you don't want to bother adding these up, just go vars, number 5, and it should be n. Okay, so just times n there. So we got 19. If it was a normal curve, we'd actually expect it to be 17.285. Okay, I'm going to find the rest of these the same, so I'll go through this, but if you get bored by it, just go ahead and fast forward to the next part. Okay, so normal CDF, number 2. Okay, this time the lower limit is 58.5. And we're going from 58.5 to 67.5. Okay, I'm just following. Isn't it just number 17 the problem? This should still be x bar. This should still be sx. Take it, paste it. And I know our value is 200, so instead of n, I'm just going to put times 200. Okay, we should expect 62.68 if this was a normal curve. So it's actually pretty close. It looks like we are a normal distribution. We'll go ahead and finish the problem though. 67.5 here. 76.5. Go down to paste. Hit enter. Times 200. Hit enter. 78, again, pretty close. Got 2 more to do. 76.5. 85.5. Go down to paste. Times 200. Hit enter. 1 more. Again, wow, that's really close. 34, 34. Okay, number 2. 85.5, 94.5, go down to paste, times 200. All right, and again, that one's pretty close. So this looks like it's going to check out. So these are your expected values. Okay, and I think on the online it says round these to the nearest integer. So you'd put 17, 63, 79, 34, and 5. Number 2, part B, find the critical value. Okay, critical value. That'd be math, numeric solver. Okay, we have 4 degrees of freedom, so I'm going to keep that as 4. And 99th percentile, or 1 minus our alpha value of 0.01, either one. Okay, solve this. So this is going to give us our critical value. 13.277 is the critical value. So we have a normal distribution, 13.277. So chi squared, we're right here. This would be our x0 squared. If our x squared is greater than our x0 squared, then we're going to reject. Right? If x squared is greater than x0 squared, this is chi squared critical value, 0. Okay. So now we got to find the test statistic. So that would be, we'd go to, so we have, where did we have this saved? I got to check this real quick. So L2 is our observed, L3 is our expected. So we want to go to stat, tests, goodness of fit test. Okay, L2 is our observed, L3 is our expected, and we have a degrees of freedom of 4. Go down to calculate. So we got a really small chi value. We got a chi value of 0.608. If you're looking in the back of the book has 0.613. So if you calculate this by hand, you'll get a chi squared value of 0.613. If you use the calculator like we just did, you'll get 0.608, which is way over here. 0.608. We are not in the rejection region, so we're going to fail to reject. What this means is we think this distribution is normal. We could also use the p-value. Remember, when p is less than alpha, we reject. Well, this is much greater than alpha. 0.96 is bigger than 0.01. So we're going to reject. We're going to, fail to reject HO. So there's not enough evidence at the 1% level of significance to reject the claim that we are a normal distribution. So there you go. If you do number 18, the back of the book or the answers for that one is 1.029, but if you use your calculator, you should get 1.012. So hope this helps. If you have any questions, just ask.